What's up, everyone? On November 9th, astronomers captured something that's breaking every rule we thought we knew about physics. An object in space is losing 50 billion tons of material every single month. But here's the problem. Scientists calculate it only weighs 33 billion tons total. Let me say that again. It's losing more mass than it actually has. And if that wasn't strange enough, this thing is traveling backward through our solar system in a direction that only happens with a 1 in 500 chance. The images we're seeing are absolutely mind-blowing, and the math behind this discovery is causing serious debates in the scientific community right now. Before we dive deeper into this story, make sure you hit subscribe and turn on the bell so you don't miss the next video. Alright, back to it. So let's talk about what we're actually looking at here. The images captured on November 9th show jets of material stretching millions of kilometers into space. We're not talking about something small. The jets pointing toward the sun are reaching about 1 million kilometers, and the ones pointing away are stretching almost 3 million kilometers. To put that in perspective, the distance from Earth to the moon is roughly 400,000 kilometers. These jets are 7 times farther than that. But here's what makes this absolutely insane. Back in July, the Hubble Space Telescope observed this same object and saw just a small glowing cloud around it. What we're seeing now in these November images is 3,000 times bigger than what Hubble captured just a few months ago. Think about that for a second. 3,000 times bigger in a matter of months. Now, if you know anything about comets, you know they typically have one main tail that points away from the sun. That's because of solar wind, which acts like a cosmic leaf blower pushing gas and dust backward at over 800,000 miles per hour. But this object has jets pointing toward the sun, actually pushing against that wind. For jets to push against solar wind and stay together for 1 million kilometers, they have to be incredibly dense and incredibly powerful. This isn't normal behavior, and it's raising serious questions about what we're actually dealing with here. Now here's where things get really weird, and this is the part that has scientists completely baffled. Avi Loeb, a prominent astrophysicist, did the calculations on how much material these jets are carrying away from this object. His estimate? About 50 billion tons of material every single month. Now, when objects move through space, their trajectory is determined by their mass. By tracking this object's movement and how the sun's gravity affects it, scientists calculated its total weight at around 33 billion tons. Let me break this down clearly. The object weighs 33 billion tons. It's losing 50 billion tons per month. You don't need to be a mathematician to see the problem here. How can something lose more mass than it actually has? It's physically impossible for a solid object to do this. The math literally doesn't work. And this is where things get fascinating, because we've actually seen something similar before. Back in 1992, astronomers discovered Shoemaker-Levy 9, a comet that passed too close to Jupiter. The planet's gravity ripped it into 21 separate pieces, and when those fragments slammed into Jupiter in July 1994, each impact created explosions visible from Earth. The scars were bigger than our entire planet and stayed visible for months. Here's the interesting part. The total amount of material that Comet released was way more than what scientists initially thought it weighed. But once they realized it had fragmented, everything made sense. When the sun heats up an icy object, it doesn't heat evenly. The side facing the sun gets scorching hot, while the other side stays freezing cold. These temperature differences create massive stress inside the object, building and building until the whole thing literally shatters like glass under pressure. When you break something into smaller pieces, you suddenly have way more surface area exposed to the sun. More surface area means more ice melting simultaneously. More melting means more gas shooting out in every direction. If this object has shattered into hundreds or even thousands of pieces, that would explain the 7 jets astronomers observed on November 8th and the massive multi-million kilometer jets in the November 9th images. Each tiny fragment would be melting and creating its own jet, and all those jets combined would add up to the enormous amount of material Loeb is calculating. It's the only natural explanation that makes the math work. Another comet called Holmes did something similar in 2007, suddenly brightening and creating a huge expanding cloud from fragmentation. So we know this can happen naturally. But here's the catch. As of right now, we don't actually know for sure if this object has broken apart. If future observations show it's still in one solid piece while producing these massive jets, we're looking at something completely unprecedented. But wait, There's more strangeness to unpack here, and this is where the statistical oddities start piling up. This object is traveling in what astronomers call a retrograde orbit. Imagine looking down at our solar system from way above the North Pole. All the planets orbit counterclockwise around the Sun. Earth, Mars, Jupiter, everything goes counterclockwise. But this object is going clockwise, traveling in the opposite direction compared to literally everything else in our solar system. Only about 1 or 2% of objects do this, and most of those are tiny moons that were captured by planets long after the solar system formed. Finding something this massive on a retrograde orbit is already unusual. But here's what makes it even stranger. Its path lines up almost perfectly with the ecliptic plane, that flat disk where all the planets orbit. Most objects coming from interstellar space arrive from random directions, steep angles above or below that plane, but this thing came in almost perfectly aligned with it. The chance of that happening randomly? About 0.2%. That's a 1 in 500 chance. Now, some of you might be thinking about Oumuamua, that weird interstellar object that passed through in 2017. Oumuamua had its own set of bizarre statistics and unusual behaviors. Its shape seemed elongated like a pancake, its brightness changed in strange ways, and most puzzling, it accelerated slightly as it left our solar system in a way that was hard to explain with normal ice outgassing. Avi Loeb wrote an entire book arguing Oumuamua might not be natural, suggesting it could be something like a light sail. Most astronomers think it was probably just a weirdly shaped comet made of hydrogen or nitrogen ice, but the debate continues. The key difference? Oumuamua was tiny, maybe a few hundred feet long. This object is gigantic, over a mile wide and weighing billions of tons. So, where does all this leave us? The fact that this object is huge and on an unusual retrograde orbit doesn't necessarily tell us much by itself. Weird orbits can happen naturally. But when you combine that with the mass loss problem from the November 9th images, you've got one of the most fascinating mysteries astronomers have ever encountered. If it's fragmented, the mystery is solved, and we're just watching a dramatic natural event unfold. But if future observations prove it's still one solid piece while continuing to produce these massive high-speed jets, we're looking at the first object ever discovered that doesn't fit any previous pattern we've seen. And that would be extraordinary, because there's simply no way a solid object can lose more mass than it weighs. That would require extraordinary evidence and potentially force us to rethink what we know about physics. Right now, all we can do is wait for more observations and see what the data tells us. This is science in real time, and whatever the answer turns out to be, it's going to teach us something completely new about our universe. Make sure you're subscribed so you don't miss any updates on this story, because trust me, this is just getting started.